Alright, so from first principles, let's basically get to also add um, the root of 3x plus 1. Let's say our y is equal to that. How do we differentiate this from first principles? Okay, our definition, the limit as h approaches 0 for the function of x plus h minus f of x divided by h. Okay, so our f of x is the original function you have, original equation, and then f of x plus h is basically substitute where there's x in the equation, put x plus h. So where there's x, we're going to put x plus h plus a 1. Okay, so feel free to pause the video, substitute the 2 in the equation, and then be able to determine the answer. Okay, avoid avoid substituting 0, not until the h on the bottom is actually dealt away with. So we're going to have the limit as h approaches 0, and then for our f of x plus h we have the root of 3x plus h plus 1 minus the root of 3x plus 1, okay, divided by our h. Is there anything we can do to this? Obviously, so it's supposed to multiply by the conjugate, right? So the conjugate requires you to change the sign in between. So 3x plus h plus a 1, and then the sign will change to positive. That would be 3x plus 1. All this should also be repeated to the denominator. Okay, so for the numerator it will be very easy. What will happen? So this part multiplied by that part, they're actually going to, the square root will disappear. You remain with 3x plus h plus 1 equal to this part times that part. It will be negative, okay, and then what will be in the brackets will be 3x plus 1 as well. All this being divided by the product of h with the square root of 3x plus h plus 1 plus root of 3x plus 1. So we actually avoid distributing the h on the denominator because we actually want it to be factorized as it is, so that we can actually divide it with what will remain on the top. Okay, so this is all very intentional and very strategic. So the limit as h approaches 0, for the top part, if you distribute the 3, which is like coefficient of the brackets, you're going to have 3x plus 3h and then plus the 1, and then if you distribute the negative to the other part of the brackets, you're going to have minus 3x and minus the 1 divided by h. Okay, the brackets remain the same, we don't want to tamper with it. 3 open bracket x plus h plus a 1 plus root of 3x plus 1. Okay, as simple as that looks. So if we try to subtract what we have on top, 3x minus 3x, 1 minus 1. Okay, so on the top you're only going to remain with 3h, and then so that h can actually divide with the h on the bottom, so that you just remain with the limit as h approaches 0, or I can actually decide to show that on the next step so that will follow. The limit as h approaches 0, 3h over h plus 1 plus root of 3x plus 1. Okay, so this and that can actually divide. Okay, and then you remain with a limit as h approaches 0. On top you have the 3, and then on the bottom you're just going to remain with the root of 3x plus h plus 1 plus root of 3x plus 1. Okay, great, right? So at this point, if I to distribute now where there's h, we put a 0. We're going to add 3 over root of 3x plus 0 plus 1 plus root of 3x plus 1 again. Now we have the limit. You can actually forget about it. So we have 3 on top over this brackets, the x plus 0 is just going to be x. So you end up with 3x plus a 1. So the square root of 3x plus 1. The other bracket is also 3x plus 1. So you end up with 3 over 2 3x plus 1. Since take a coefficient of a 1, and then if you add them, since they are of the like terms, you end up with a 2 of them. So basically this is your answer, or this is your derivative of that, okay, from first principle. The concept is basically the same for all kinds of questions they can ever give you under this topic. Okay, so it's a matter of you coming up with a strategy or a way of actually removing the h which is on the denominator so that you don't divide by 0 and be able to compute and simplify.